In this video, I will cover the basics of simple probability. Steps for calculating simple probability. I want to use an example using this jar shown to the right with some different colored marbles. And the example question is, what is the probability of selecting a blue marble from this jar? So the first step is to count the number of possible successes, we call them. A success, in this case, is a blue marble. So I see 1, 2 blue marbles. Second, count the total number of possible outcomes. This is simply the number of things that we could select in the case of a jar. Now, we want to count the total number of marbles. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 marbles in this jar, so that is the total number of possible outcomes. Then we simply make a ratio, the number of successes on the top of the ratio over the number of total possible outcomes. That would be 2 over 8, or 2 to 8. However, with probability, we always want to try to reduce that ratio if possible. We reduce that ratio just like we would a fraction. You can use the calculator to do that, or it may be obvious to you that 2 over 8 reduces to 1 over 4. That's it. That's all there is to simple probability when there's only one event involved. In this second video on probability, I'm going to talk about some of the complications that you can get into with probability problems. Probability problems can get trickier when there's more events. So far, we've only talked about one event. Let me give you some examples. Rolling 2 or more 6-sided cubes would be more than one event. Flipping 2 or 3 or 4 coins. Spinning a wheel twice. Picking 2 balls from a jar. Those are all examples where there's more than one selection being made. Now, the key idea that we're going to use for problems with more than one event is to multiply the probabilities together. Let me give you some examples of that. So let's say the question was, what is the probability of picking a red ball from a jar and then another red ball from that jar? We're going to calculate that by multiplying the probability of that first event, the first red ball, with the probability of getting the second red ball. When we take the product of those two probabilities, it will give us our answer. Other examples, the probability of getting a head when flipping a coin, and then when flipping it again, getting a tail. So we'll multiply the probability that the first is a head with the probability that the second flip is a tail. Finally, the probability of rolling 3s on a dice, 3 3s. So we're going to multiply 3 things together this time because there are 3 events. We are going to roll 1 dice, we'll roll another dice, we'll roll a third dice. We'll just multiply the probability of those all together to get the answer. We'll be going through some examples of this. First, a note about multiple events. Rolling 2 6-sided cubes may sound like one thing. We're just doing one thing. We're rolling these 2 cubes. Or selecting 2 marbles from a jar might also sound like we're just doing one thing. But we need to think of these each as 2 events. One is happening after the other. So for the cubes, we think about rolling 1 cube, something's going to happen, and then we roll the second one. That's how we get those 2 probabilities that we're going to multiply together. With the marbles, the same thing. We're going to pick one, and then we're going to pick the second one, even though it says selecting 2 marbles. So, as I said before, roll the first cube, then roll the second. Those are the 2 events. Pick 1 marble and then select another. 2 events. Steps for calculating the probability with more than one event. I've already talked about this, but we're going to go through this step by step now with an example. What is the probability of flipping a coin and getting two heads in a row? We find the probability of the first event, the probability of flipping a coin and getting a head. In this example, that is 1/2. There's one head on a coin and there's two sides. So the nice thing about coins is that the probability of getting a head will always be 1/2. The probability of getting a tail will always be 1/2. The probability for coins are always the same, which makes them kind of easy to work with. Number two, what's the probability for the second event? The probability that the second is ahead is also 1/2. It will always be 1/2 for a coin. So now we have the probability of our two events. If we had a third, fourth, fifth event, we would have to find those probabilities, but that doesn't apply. In this case, we just have two events. Now we multiply those probabilities together using a calculator, if necessary. In this example, it's 1/2 times 1/2 to give us our answer of 1/4. You will want to try to reduce that probability if you can, but we can't in this case. So our answer would be 1/4. Hopefully that makes sense. We're multiplying these together because we have a probability for each event. In this video, I'm going to cover combinations and permutations. What these problems have in common is they usually have the phrase, how many ways in the word problem. How many ways can we select a certain number from another number? So let's take a look at a review of the three different kind of problems that fall under this category: permutations, combinations, and combinations of types. So the first example we have is of permutations, ways that 6 horses can finish in the top 3 places in a race. Order is important. That is what we need to keep in mind when we're looking for a permutation problem. Is order important? If it is, then it's a permutation problem. We're going to calculate that using the PRB key on the calculator and then the NPR function. I will review that in a moment. A combination example, ways to make pizza with 2 out of 5 possible ingredients. We don't care which order ingredients are added to our pizza, so order is not important, and that's what makes this a combination problem. To do this calculation, we're also going to use the PRB key, but we are going to select the NCR function. C stands for combination. Combination of types is a little bit different, and we're going to calculate it without the PRB key. An example would be ways to get dressed with 2 different shirts, 3 different pants, and 5 different pairs of shoes. The order isn't important. We're just selecting one of each of those kinds of items. And the way we're going to calculate that is to just multiply the counts together. 2 times 3 times 5. That's what makes a combination of types problem pretty easy. The calculation is very simple. So it's usually a little bit of a challenge. You might recognize that this is a how many ways problem, but is it a combination or is it a permutation? Combination problem examples. Making a pizza with different ingredients. I already talked about that. We don't care what order the ingredients are added, so order is not important. Selecting people for a committee. They're all on the committee. There's no particular positions, so we don't care about the order they were selected. Buying some items off of a list. When you come home from the store and you bought 5 out of the 10 items on your list, you don't care which order you bought them in. You just have those 5 items. And sometimes the question will actually state that order doesn't matter. That makes it easy. Permutation examples. The top X positions for the race, the top 2 positions, the top 5 positions. Electing people to specific positions like president and vice president and treasurer, we can think of that as a situation where the order that they were selected is for a particular position. Selecting things to be done in a specific order, like an instruction list. And the question may actually state that order matters. Identifying a combination of types problem. These look pretty different, so they shouldn't be too difficult to identify. There will be quantities of different things, and you will be picking one of each. For example, getting dressed with different number of shirts, pants, and shoes. Making a pizza with 1 meat, 1 veggie, and 1 cheese, and there's different quantities of those items. Picking a running shoe when there's 5 colors, 4 sizes, and 3 styles. Another example. In this video, we will talk about solving problems using charts and graphs. There are 5 different types that we will be reviewing here. The first is a pie chart, then a line chart, bar charts, picture charts, and finally dot plots. Let's get to it. Here is an example of a pie, or sometimes called a circle chart. Let's take a look at what this chart is communicating to us. We read the title. It tells us that this is a sports camp weekly budget, and the budget amount is $2,250. That means the whole circle represents $2,250. The percentages around the circle tell us what different parts of the budget represent of that $2,250. Let's take a look at the kind of question that you might be asked about a chart like this. What percent does the camp spend on the 3 largest categories? In order to find the 3 largest categories, we're looking for the 3 largest pieces of the pie, so to speak. Those would be the bus costs, the equipment costs, and the lunches. We could also look at the percentage numbers and pick the 3 largest numbers, but we then want to add these together, and we can just add percentages to each other without converting them to a decimal first. And we're going to add those 3 numbers, and those add up to a total of 81%. So that would be the answer to that question. Let's take a look at another question that we could ask about the same chart. How much does the camp spend on umpires? Well, down here, it tells us that we spend 11% on umpires, and it's 11% of this amount. So using our percent shortcut, 11% of 2,250. We convert 11% to a decimal. That'd be 0.11. We convert of to multiplication, and this stays the same. We multiply that out, and you get 247.5. But remember that we're dealing with money, and we should always have 2 values after the decimal, so we add the 0 there. $247.50. Let's take a look at another chart type here. This is an example of a line chart, and line charts are usually used to communicate how something changes over time. Here we can see we have months of the year on the bottom. The topic of our line chart is the number of emergency room visits related to scooter injuries, and they're at a particular hospital, Westfield Hospital or Westside Hospital. Over here, we have the number of ER visits. So for charts like this, sometimes we are going to have to estimate what the values are. For instance, if we were trying to figure out what this amount is for November, we have to look at that and then try to figure out what that would be over here. So we might estimate that that is most of the way to 100 from 80. So maybe that's 95. We're not worried about whether we get that exactly right. Our estimates will be good enough to answer a question like this. All right, let's take a look at a question that could be asked about this chart. Which month had the largest number of visits? This is a pretty easy question to answer. We look for the highest point on the chart. That will give us our largest number of visits. And it appears like that might be about 105. But we're just interested in answering with the month of September. That had the largest number of visits. Next question. Which month had the largest increase in the number of visits? This is a little bit trickier because what we have to do is to look for the steepest line in this chart. That's the steepest line. If we were thinking of this as being riding your bike here, this would be the steepest part of a hill to ride your bike up. So we are pointing to the month that would have the largest increase in the number of visits, August. If we were looking for the largest decrease, we'd be looking for the steepest line going down and the month that would be pointing to from going from left to right. Welcome to this video on mean, median, mode, and range. These statistics, mean, median, mode, and range, are 4 different ways to help us describe a set of numbers with a single number. We have this example of 7 numbers here that we're going to be working through these statistics on. We're looking for a single number that can describe various things about this set of numbers. And that's what those statistics are for. So let's take a look at the first of these. It's called the mean. You might know it as the average. They are the same thing, no difference. So this is the one that you're probably most familiar with. We take the sum, add up all of the numbers, just add them in sequence, and we get 140. Then we count the numbers. How many are there? 1, 2, 3, 4, 5, 6, 7. There are 7 values in this list. Now we're going to put those 2 things together by dividing the sum by the count. The mean is going to be 140 divided by 7, 20 in this case. Our mean is 20. Okay, let's move on to the next one. It's called the median. What that means is what number is in the middle of our list. But in the middle of our list, when it's organized from smallest to largest. So that's the first thing that we need to do, is to rearrange this list in order. This is the list rearranged. Notice that 4 is the smallest number. 8 is the next smallest. There's 2 of them. And 15 is next, 20, 35, and 50. Make sure that you have the same number of values in your rearranged list so that you didn't skip anything or add an extra one. There are 7 numbers up here. There are 7 numbers here. It looks like we're good. Next, the median will be the number in the middle. Because we have an odd number of values here, 7, the median will be the number right in the middle. Notice there are 3 on the left and 3 on the right. So 15 is right in the middle. That is our median. Now, if there's an even number of values, there will not be a middle number. So we need to use a slightly different procedure. The median will be the average of the 2 in the middle. So I took one value out of this list. Now we only have 6. And notice that the middle is right here between 18 and 20. We don't have a middle number. So we highlight those 2 that are in the middle on either side of the middle, and we take the average of those. 18 plus 20 divided by 2, 19. It makes sense. 19 is right in between 18 and 20. So that's our median for that second list. Now the mode. which number appears the most. It is helpful to rearrange the numbers in order to get the mode, but it's not absolutely necessary, but I will do it here. We'll put up that same list in order. And then as you scan from lowest to highest, it becomes clear when numbers are repeated. And that's what you're looking for, which numbers are repeated. In this case, we can see that 8s appear twice. The number that appears the most times is the mode. So the mode is 8. No other numbers appear twice in this list. If no numbers repeat, then there is no mode. There does not have to be a mode for a list, only when numbers repeat. That makes it a little bit unique. Let's look at the last one. The range. How spread out are the numbers? Find the smallest and largest numbers. Scan your list. Look for the smallest number. We already identified that to be 4. Look for the largest number. That's 50. Double check your work. Make sure that there's nothing larger or smaller than those two numbers. If you're good, subtract the two. Subtract the smaller number from the larger number. 50 minus 4 equals 46. That is the range for that set of numbers. It's a measurement of how spread out it is.